Okay, is my screen visible to all of you?
Yes, sir.
Yes, sir.
This is our unit 1. We are proceeding. Okay. So today we'll see the length contraction. Length contraction means due to the relative motion of the frame, or say due to relative motion of the frame of reference, the length is found to be contracted. That is what we are going to see here, or say prove the expression for the length contraction. So consider the diagram. So this is the frame S. Okay, this frame S X Y Z O. Okay, O means origin, or say position of observer, you can imagine. And this is the inertial frame S. Okay, which is stationary, which is not moving. The stationary frame S which is not moving, that is XYZ. Okay, this is X O Z Y. Okay. Sorry. And there is another frame, inertial frame S dash. So this is another frame, inertial frame, which is moving with uniform speed v with respect to S dash frame, that is denoted by y dash, x dash, z dash, and o dash. So there are two frames. This frame S is stationary, and this frame S dash is moving horizontally along x direction with uniform speed, say v. Now, so there is a rod. There is a rod of rod AB. Okay, whose coordinates, this is the rod AB, this is A, this is B, and here the coordinates of A with respect to this origin O dash is x1 dash, y dash, z dash. The coordinates of A with respect to this observer O dash, or say origin O dash, is x1 dash, y dash, z dash, and coordinates of this point B is x2 dash, y dash, and z dash. Now here the origin O and O dash, okay, this O is stationary, O dash is moving. Okay, so initially O and O dash, they are at this point. Okay, initially they are coinciding. After time t, as O dash is moving, okay, moving along x axis, after time t, it will reach the position, or say it will be transferred to this position, and the distance traveled is v into t, because this frame S dash is moving with uniform speed v. So this is continuously moving, and this rod AB, where coordinates of A are x1 dash, y dash, z dash, and B has coordinate x2 dash, y dash, z dash. Okay, is that clear? This is the situation. Now let us find the length measured by this observer O. Now the length of rod measured by this O dash is simply x2 dash minus x1 dash. Length measured by this observer O dash is simply x2 dash minus x1 dash, because this rod is along x-axis. So there is no coordinate variation along y-axis and z-axis. So its length can be measured by simply subtracting the x coordinates, that is x2 dash minus x1 dash gives the length of rod AB. Okay, and that is with respect to the observer O dash. Now we will find the length of rod with respect to the observer O. So that will be, we make use of Lorentz transformation equations. So here L0 is the length observed by observer in S dash frame. Okay, so this is the original length, that is x2 dash minus x1 dash is equal to L0. So this is measured by O dash, that is S dash frame. Okay, that is the original length. So the length observed by the observer O, okay, this is O. So let us find the length L here by using the Lorentz transformation equations. So L0 is equal to AB, as I said, x2 dash minus x1 dash, and L is equal to x2 minus x1. So x1 and x2 are the coordinates, x coordinates of A and B when measured by the observer O, or say measured by the observer in frame S, which is stationary. Okay, so that is the specification, and we know that by Lorentz transformation equations, x1 dash is equal to x1 minus vt upon under root of 1 minus v square by c square. Similarly, x2 dash will be x2 minus vt upon under root 1 minus v square by c square. So x2 dash minus x1 dash, that becomes x2 minus x1 upon under root 1 minus v square by c square. So that gives you the value, that is L0 is equal to L upon under root of 1 minus v square by c square. Therefore L is, which is the length measured by the observer O, which is in stationary frame, is equal to L0 under root of 1 minus v square by c square. So here one may find that the L is less than L0. That means the length measured by the observer, which is observer who is in the stationary frame, will find the length which is less than the original length. So length will be contracted. So this is also known as the Lorentz Fitzgerald contraction. Okay. Any questions regarding this? May I audible? Hello?
Yes, sir.
Hello? Okay. So we'll go to the next topic, that is time dilation. So what happens to the time? Now delta t dash is equal to say t2 dash minus t1 dash is the time interval measured by the observer in S dash frame. So the rest all the things will be same. We are just talking about the time. So time interval is nothing but the difference of time. Okay. So t2 dash is and t1 dash is the uh, time noted by the observer in S dash frame. So the time interval will be delta dash. Similarly, delta t will be the time interval as measured by the observer in S frame. And we know that by uh, Lorentz transformation equations, t1 dash is equal to t1 minus vx upon c square upon under root 1 minus v square by c square, and t2 dash is equal to t2 minus vx upon c square under root of 1 minus v square by c square. So if you minus, okay, so subtract equation 1 from 2, so you will get T2 dash minus T1 dash is equal to, you will get finally T2 upon T1 upon under root of 1 minus B square by C square. So here you will get delta T dash is equal to delta T upon 1 minus V square by C square. So here delta T dash is greater than delta T. That means the time interval measured by the S dash frame, time interval measured by the S dash frame is greater than the time interval measured by the stationary frame. Okay. So suppose certain event is occurring. Certain event is occurring. Okay. And we have to measure it from S dash frame as well as S frame. Okay. So the time interval measured by the observer in moving frame will be greater than the time interval measured by the stationary frame. So that is what the time dilation. So we'll conduct numerical problems based upon this length contraction and the time dilation later. Okay. Now we'll continue our next topic, that is addition of velocities. What happens to the velocity due to the Lorentz transformation equations? Okay, so let us see. So we know that x is equal to k into x dash plus vt dash. That implies dx is equal to k into dx dash plus vt dash. T is equal to k into t dash plus vx dash upon c square. So that implies dt is equal to k into dt dash plus v into dx dash upon c square. Okay. Now let us, for the velocity we need dx by dt. So dx by dt is equal to, if you just divide the right hand side, you will get kk will cancel. So dx dash plus vt dt dash upon dt dash plus v dx dash upon c square. So if you further multiply numerator and denominator by dt dash, so you will get dx dash upon dt dash plus v. So dt dash cancels upon 1 plus vx dash vx dash upon c square dt dash. Okay. So that will be equal to, so dx by dt is nothing but the ux. Okay, it is the velocity, and dx dash by dt dash is nothing but the u dash x. Okay, ux dash you may call it as, plus v upon 1 minus v upon c square ux dash. Okay, so this is the velocity. So for the y, actually the frame of reference is moving along x direction only with uniform speed. So there is no change in the y coordinates. Therefore, y is equal to y dash, dy is equal to dy dash. So dy by dt will be equal to just dy dash upon the dt. Okay, and what is dt? dt is equal to k into dt dash plus vx dash upon c square. So if you solve this, you will get uy equal to uy dash upon k into 1 plus v upon c square ux dash. Okay. So finally you will get the value of uy as in terms of uy dash and uz as in terms of uz dash. So it is not simply uy is equal to uy dash. Okay. So there is a change. Even though there is no motion in y direction and z direction, the velocity components may vary due to the relative motion of the frame of reference. So that is what the important result. So these are the velocity compounding, or say addition of velocities. Okay. So let us stop here. Before we stop, these are the transformations of velocities. Okay, as I said, ux is equal to ux dash plus v upon 1 plus v upon c square ux dash, and uy is equal to uy dash into under root of 1 minus v square by c square upon 1 plus v upon c square ux dash. Okay, and uz is equal to uz dash under root of 1 minus v square by c square upon 1 plus v upon c square ux dash. Okay, now we can write these transformation equations by using, say, taking ux dash on left hand side. So they are called the inverse Lorentz transformation equations, as we have seen. So for writing inverse transformation equations, we just replace v, small v, which is the speed of frame, is replaced by minus v. That is the simple equation. That is, so ux dash, okay, is equal to ux minus v upon 1 minus v upon c square into ux dash. Uy dash is equal to uy into under root of 1 minus v square by c square upon 1 minus v upon c square ux, and uz dash is equal to uz into under root of 1 minus v square upon c square upon 1 minus v upon c square into ux. So these are the velocity compounding. Okay, so yes, so I will stop here. In the next lecture, we will see the velocity, relativity of mass. How the mass changes occurred because of the relative motion. Okay. So, any discussion, any questions regarding this?
Hello, sir.
Hello.